Hello everyone. Before starting this lesson, please try the warm-up. Here's the triangle. We're solving for x. This is Bob's work on the left. This is Brenda's work on the right. Find each student's mistake. So pause the video, see if you can find the mistake, and check back in. Because we're trying to find the hypotenuse and we know the opposite side in this case, opposite and hypotenuse, that should be sine, not tan. So there was Bob's mistake. And Brenda, well, she used sine. Sine of 53 is opposite 10 over hypotenuse x, so that's correct. But the next line, to solve for x, it's not going to be 10 times sine 53, it's going to be 10 divided by sine 53. So that was her mistake right there. Hopefully this reminded you of a few little details that you might have forgotten from the last lesson. This lesson is about solving problems involving right triangles. So our goal is to solve multi-step trigonometry problems. These problems could involve Pythagorean theorem or the primary trigonometric ratios, sine, cosine, and tangent. And I say multi-step problems because sometimes you have problems that you can't solve by doing one calculation. You have to do a few calculations in order to get enough information to solve. So one key idea before we get going on any examples is that if a situation requires a length or an angle, try to represent the problem with a right triangle model. If you can, solve the problem by using the primary trigonometric ratios, sine, cos, or tan. So as we're reading through these problems, it's a good practice to make a diagram. See if you can represent it as a right triangle. And if you can, then you can solve the triangle using Pythagorean theorem or sine, cos, or tangent. Here's a problem that you should copy and follow along with. Determine the area of this triangle. So as a reminder, area of a triangle is equal to base times height divided by 2. Base and height are perpendicular to each other, which means they're at a right angle. So one thing you can do is just imagine the height here, perpendicular to the base of the triangle. So I know my base is 11 meters. I don't know the height, but if I did, then I could calculate the area of the triangle. So really this problem boils down to solving for the height. This is a right triangle that I drew here. I know this angle, 40 degrees. I know the hypotenuse of this triangle, and I'm trying to find the opposite side. So if I have opposite and hypotenuse in my equation, I'm going to use the sine ratio. Sine theta equals opposite over hypotenuse. Now plug in what I know, solve for h, and now I know the height of the triangle. Before I move on, I just want to point this out. I'm not using the adjacent side in my calculation because if you think about it, this 11 meters is the distance from here all the way to here, but in the right triangle, I don't know how long this side is because it stops here, and I don't know this little distance over here. So I don't know how far it is from here to here. I can't use the adjacent side in my calculation. That's why I chose to use the hypotenuse instead, because I know what it is. So if you thought you could use cosine to solve for the height, you would not be right, since you don't know what the adjacent side is. Okay, so we know the height of this triangle is 8.4 meters. We know the base is 11 meters. So we can use our area formula to find the area of this triangle. Area is base times height divided by 2, so 11 times 8.4 divided by 2, it's approximately 46.2 meters squared. So in this problem, I wasn't given a right triangle, but I created a right triangle model so that I could find the height, which is what I needed to solve this problem. Now here is an example that I would like you to try on your own if you can. First I'll read it. A surveyor stands at point S, that's here, and takes the measurements shown in the diagram in order to determine the length of the building lot. How long is the lot? AB. Now, upon reading a word problem like this, it's important to take your time to try to understand how to visualize what's going on. If you don't know what a surveyor is, look it up. A surveyor is a person who surveys the land. They take measurements so that at a construction site, for example, they can know how high a hill is, the distance between 2 points, things like that. So S is the point where the surveyor is standing. If we follow this diagram, here's the building lot. The goal is to figure out how long the building lot is from A to B. That's what AB means. So our goal is to find the distance from A to B. The surveyor took these measurements. They measured the distance from where they're standing to this end of the building lot. It was 347 meters. And they took another measurement of the distance from where they're standing to the other end of the building lot, which was 150 meters. They picked a point labeled P that is on the building lot, but perpendicular to where they're standing and the length of the building lot. They measured the angles on either side of that. So here are all the measurements. Our goal is to find the distance from A to B. It looks like we have two right triangles. And now it's up to you. Pause the video, see if you can figure out the total distance from A to B, and then check back in to see how you did. So the way I did this was I split the entire distance into two. I called it X and Y. X is the side length in this larger right triangle. Y is the side length in this smaller right triangle. In the larger right triangle, my reference angle is 69 degrees. X is the opposite side. 347 is the hypotenuse. Opposite, hypotenuse, I'm using sine. Sine 69 is opposite over hypotenuse, x over 347. To solve for x, it's 347 times sine 69, and I get 323.95 meters. In the smaller triangle, the reference angle is 34 degrees, y is the opposite side, 150 is the hypotenuse. So again, I'm going to use the sine ratio just with a different angle and a different hypotenuse. So I solve for y, I get 83.88 meters. The total distance from A to B is just x plus y. So I add those numbers together and I get 407.83 meters long. Now you might have done the same method and got a slightly different final answer. Because of rounding issues, you might have rounded this to 324 meters, you might have rounded this to 84 meters. You would get just a slightly less precise answer than I got. If you're concerned about it, just let me know. I can tell you if you're on the right track or not. And this last example in this lesson is pretty tough. So this is an example of a really kind of difficult question, but you can solve it using the primary trigonometric ratios that we've been talking about. It's also going to require a little bit of algebra. So this is more of an extension question. How tall is the communications tower? So this is the communications tower. Let's pretend we took these angle measurements. So somebody stood at the bottom of this building and they measured the angle of elevation looking up to the top of the tower, and it was an angle of 33.4 degrees. We know that this building is 70 meters tall, That's where this came from. And at the top of the building, the angle of elevation looking up to the top of the tower was measured again, and this time it was 11.2 degrees. So that's where these angles came from. And we know the height of this building was 70 meters. And with these two angles and this one distance, we can figure out the distance or the height of the tower from the ground all the way to the top. I'm going to put my full solution on the screen, and then I'm just going to talk through it. It's a little more complex. I'll start with this. I'm going to label the distance from the base of the building to the tower as D, D for distance. Now this space in here, I don't know from the top of the building to the top of the tower. I'm just calling it A. So if I look in this small triangle here, from the reference angle 11.2 degrees, A is opposite, and D would be adjacent. So I'm going to use tangent. That's where this came in. Now I don't know what D is, but if I was solving for A, it would be D times tan 11.2. Now if I look at the big triangle, I've got an angle. The opposite side would be 70 plus A, or A plus 70. That's the total length of the opposite side. And the adjacent is D. So tan 33.4 equals opposite A plus 70. That's the entire side, divided by D. That's the adjacent side. And again, if I want to solve for A, well, A plus 70 equals D times tan 33.4. That's where this came from. And to solve for A, I got to take away 70 from this side. I take away 70 from this side too. So A is equal to D times tan 33.4 minus 70. Now look what I've done. I've solved for A two different ways. So A is equal to D tan 11.2, and also A is equal to D tan 33.4 minus 70. Now, A is A, so that means D tan 11.2 is D tan 33.4 minus 70. So I can make that into an equation. Now, if you look at this equation, there's only one thing that I don't know. There's only one variable that I have to solve for, D. Now, it looks a little complex because tan 11.2 and tan 33.4, they look complicated, but remember, these are just numbers. You can get this value in your calculator, 0 point something or other. So I'm going to treat this in the same way I would treat any equation that I'm trying to solve. Collect your like terms, simplify, and then solve. So now I know the distance from the building to the tower is 151.7 meters from here to here. So now that I know that distance, I can figure out what A is. I'm going to go back to this. A is equal to D multiplied by tan 11.2. Well, I know what D is. So A is equal to 151.7 multiplied by the tan of 11.2. And that comes out to about 30 meters, if I round it. And now I can actually answer the question, how tall is the communications tower? Well, it's 70 plus 30, that's 100 meters. So this is a pretty difficult example, but it is something you can do. You might have got a little fuzzy with the algebra around in here, but if you have questions about that, you can let me know. Otherwise, you can move on to practice. Look at page 280 in the textbook.